Hello and welcome to this new video. In the previous video, I showed you how to authenticate the player with the online subsystem EOS. In this video, we will start to create a basic lobby system so that we can later implement the features of Easy OSS Plugin. For example, the creation of sessions and the management of matchmaking, as well as the management of user accounts and their friends. In this video, I will not touch on the features of Easy OSS. It will just be the creation of the lobby level and the preparation of the environment for the subsystem. In the Levels folder, create a new folder and name it Lobby. In this folder, we will create a new level for the lobby. Right-click and create a new level, then name it Lobby. Double-click on it to open it in the editor. Click on Selection Mode, then on Landscape. We will create a landscape for this level. It will be a small landscape. To do this, change the size and the number of components. Click on Create and return to the Selection Mode. Now we're going to add the lighting components. Follow me and do what I do. For now, we don't have a player controller nor an associated game mode for this level. Return to Lobby folder and create these two objects. Open the created player controller and set the input mode to UI only and set Show Mouse Cursor to True. Open the created game mode, then change the associated player controller and game session class. Note for the default pawn, we will create a pawn dedicated to the lobby level. This pawn will just be a camera that faces the lobby characters. We will not use the third-person character as default pawn, because in this case each player will only see his character. Create a new pawn and give it a name, then set it as default pawn of game mode. Open the created pawn, then add a camera, then set it as default root component. Return to the level world settings and set the game mode override to the game mode that we have just created. Add a player start to the level. This will be the default spawn location of our lobby pawn. You can launch the game and see the view given by this pawn. You can then modify the transform of the player start in a way to have a clear view of your lobby. You can also change the camera settings to get a better view. Now we will create a spawn system of the character representing the lobby player. Also, the characters of the players invited to this lobby. For now, we do not have the spawn transform of each character. To implement a dynamic spawn system, there are many solutions. The solution that I will implement in this tutorial consists of spawning the character in the game mode of the lobby when the player joins the lobby, so it is in the on-post login event. To find the spawn transform of the character, I will use the transform of an actor placed in the level. To understand my point of view, just follow me and watch what I do. Create a blueprint actor and give it a name like character spawn transform actor. Open this actor and add a cube. This will be the object where the character will stand. Place this actor to your scene, then change his location in a way the character will be visible by the camera. In my example, the lobby can have 3 players. One player owns this lobby and the other 2 players are guests. To do this, duplicate the actor with a Ctrl+D and adjust the positions. Play the level to verify that all cubes are visible. Return to the game mode. In the construction script, we will get a reference for each cube actor to then save their world transform in a variable. Call the node getAllActor of class and specify the actor class that we created. This node returns you a list of actors of this class found in the scene. In our case, it will be a list of 3 actors. Now, for each actor in the scene, we will assign a tag. This tag allows us to identify the cube in the game mode. For example, the first cube must have a tag player 1, the second player 2 and the third player 3. Return to the game mode and loop through the list of 3 actors. Each array element represents an actor object reference. Get all tags for each element. The tag we created must be at index 0 of the tag list. Now we will create a variable of type map. The key of this map is the tag and the value associated with the key is the actor object reference. Like this, we can use this map at any time to find the actor transform of each player. For each array element, add new key value pair to the map, giving the key the tag and the value the actor object reference. To test the implementation, just print the tag on the screen, then launch the level. Select the script, then type C to comment. Now in our post-login event, we will test the spawn system. For now I will test the spawn on the cube of player 1. It's just to check that everything is good. Then I will automate the spawn according to the number of the player who has just joined the lobby. In my case, I will spawn the third-person character of the template. You can spawn your own character if you want. Get the actor transform of the actor tagged player 1, then connect it to spawn transform of the node. Set the collision override to adjust location, but always spawn. Launch the level and verify that the character is spawned on the first cube. Adjust the rotation of cubes so that the characters faces the camera. Test on the cube tagged player 2 to verify the expected result. Now I'm going to automate the spawn system in a way to automatically find the right cube corresponding to the player joining the lobby. Create a function and name it getCharacterSpawnTransform. Copy the selected nodes, then paste them into function. Create an integer variable representing the count of game mode players. Increment this variable on post login when a new player joins the lobby. In the function, make a switch on this variable. Since our lobby can have only 3 players, I will make a switch from 1 to 3. create a local variable in this function, then name it tag. Update this variable according to the current number of players. Find the actor reference from the map according to the current tag. Add a return node to return the corresponding actor transform. On post-login event, call this function, then connect its output to spawn actor node. Test your implementation. The character will always be spawned on the first cube. This is normal because according to his number in the game mode, he always takes the tag player 1. When we discover the sessions, we will see that the guests will be spawned on the other cubes. Now I will test the implementation on the 3 players by running the 3 batch files. For this I must first open the level lobby once the player is logged in. We must open the level lobby only if the login task completes successfully or if the player is already logged in. Remember, you can't test via the editor, because we are currently implementing the auto login method. Go to your project folder and launch the 3 bat scripts. Once the instances are launched, log in all 3 players. There you go, everything works as expected. We finally need to decrement the number of players when a player leaves the lobby. To do this, override the onLogout event. Then decrement the variable. That's all for this video. In the next video we will start creating a basic UI for the lobby level.